Okay, so we're going to look at a couple more things dealing with our histograms and our frequency distributions. So sometimes what will happen is you will have either a first class or a last class. That's what's called open-ended. Okay, so with the example we've got here, we've got 5 to 14, 15 to 24, 25 to 34. Notice that our class width is 10. Then we get up here to the top end, and instead of doing 85 to 94 and 95 to 104 and 105 to, so on and so forth, we're now doing this where we just lump everything that's 85 and up or 85 and older. That is considered an open-ended class. We're not keeping the same pattern going. Now, other times it talks about the first one. So you may have, if we were talking about, say, income, we might have below 20,000 and then 20,000 to 29,999, 30,000 to 39,999, 40,000 to 49,999. And then, but they class everything under 20,000, okay, when they do this. So this is just one of the things that you might see happen, and it is one of the occurrences where you do not have to follow the guideline that you've got. You have to follow that frequency that's running around through there, okay? So the next thing is sometimes, briefly kind of mentioned this in one of the other ones, sometimes we do histograms for what's called discrete data, which is that whole value type stuff. And so we don't actually have classes. So for this one, we're talking about the number of children. Now, obviously, this is still going to be a histogram because you can't have 1.5 children, okay? It's either 1 or it's 2 when this goes through. And so note here that the difference is when we do discrete, instead of having the lower class limit on one side and the upper class limit kind of where the bars are, that on this one, they take the value and put it right in the middle of the bar when they do this, okay? So we have our chart here, and we're running 0 to 8, and then we've got the same thing here on the histogram that we've got going on with this. And so this is what one looks like when we're doing individual things. So you might also see this here. They're talking about the number of children. It could be the number of pets, things of that nature, where you're not going to have that range of values, or you're not wanting to do kind of a range of values with that. Now, one of the other things that histograms can help us do through here is we can talk about the shape of a data, okay, of a data set. And this is where we're looking at the bars. Now, the idea here is that this is very kind of, we are not looking for precision, like exactness with this, just an overall general thing. Now, the first type is what's called symmetric. And basically what symmetric is, you could take a little bugger and fold it in half, and it would roughly line up onto itself. So if we take a look at this green data set, we can kind of see right through about here, this little lovely darling would fold in half because we have a general sloping down on each side. And granted, some of the bars on this side are higher and some of the bars on this side are higher, but we have that it's pretty much kind of matched up half and half. Now, this next one, the red one, is what's called skewed to the right. And so what happens with skewed to the right or positively skewed is we have kind of a high end here, and then it taper tails off over here to the right-hand side, okay? So kind of a general downward motion towards the right. And sometimes you will see kind of, it'll come up and then back down, or it may just start high and go down. We also have skewed to the left, which is we have kind of this long tail leading up into kind of where our higher bars are. This is also called negatively skewed. So if we take a look at a couple of our examples here. So we're going to take a look at number 2. Okay, so we've got this lovely shape. And so they're asking us, is it skewed left, skewed right, or approximately symmetric? And so this one is going to be approximately symmetric because we can run almost straight up right here with the middle being right about here. And we can see that it would roughly fold in half. Again, we're not looking for it's got to be exact fold in half, but we are looking for it's roughly the same. Okay, so then number 8, it says, we expect a histogram for the number of applications it takes for a job applicant submitted before finding a job. And they're asking us how this would be skewed. So the concept here is no applications, 1 application, 2 applications, 3 applications, 4, 5. Now, we know that there's probably going to be, and I mean, think about when you were getting a job, okay? You're not going to have necessarily a whole lot of people that just automatically are handed a job. They don't have to do anything for it. You're probably going to have some that do 1, probably a few more people that have to do 2. So I'm going to kind of make some graphings here. Okay. So maybe we've got some down here. And then, there may be a few more that have 3, and maybe we've got some more. So we see kind of this steady, and, maybe a few more that had to do 5. So we see kind of this steady up. So this would be skewed left. We would kind of think that most people are probably going to have to submit 2, 3, 4 applications before they actually get a job, okay, is what we're looking at for that one, okay? Now, one other thing that we're going to look at in this, okay, is whether or not a data set is, from a histogram standpoint, is unimodal or bimodal, okay? So now, the highest point is oftentimes called the mode. It's the thing that happens the most often, or it has the highest frequency. And so, for example, with this blue one, we have kind of 1 spike peak. And so that's called unimodal. Bimodal has 2 clearly distinct modes. So it should almost look kind of like a mountain range type of thing. So you got a high spot, you come back down into a valley, and then you're going back up to another high spot again, okay? So we do kind of have to see that. Now, looking at number 3 on our example here, so we've got this, okay? They ask us whether or not this is unimodal or bimodal. I made the argument that this is unimodal, okay? Because we've got this one high. I only have a 1 bar drop here before this spikes again. That's not enough to say it's a valley. I also don't have that, because these 2 are about the same, this single bar isn't enough for me to say I drop and then come back up to a high spot. So this is this would be a unimodal set when looking at that lovely data set for that.